Hi, Megan.
Can you hear me now?
I can't hear you at the moment.
Okay.
Oh yeah, now I can.
Now you can. Okay, great.
Cool. Yeah, nice to see you.
Nice to meet you.
Yeah. Dominic, can you?
Hello. Hi.
Hi. Cool. Great. Yeah. Well, we've still got a few minutes, but yeah, it's great that the technology seems to be working for everyone. Yeah. Yeah. Have you been enjoying the conference so far?
Oh yeah, I've been attending a lot of talks recently. So sad I wasn't able to join physically. It looks really fun.
Yeah, the time zone's pretty rough for Philippines. Yeah.
Right now it's like it's 10 p.m. here in the Philippines, so
Okay. Oh, that's not too bad. Yeah.
not too bad.
Yeah. Yeah. How about you, Megan? Have you been able to make a fair few sessions?
A few. It's been rough with trying to do both at the same time.
Yeah. Yeah, it's a busy time of semester as well, and for us especially. Yeah. Cool. Okay, we've got a pretty tight schedule with the 4 talks, so maybe if Dominic, you want to share your slides so we can check that's all ready.
Yeah, I actually wanted to test if it works.
Yeah, we'll go ahead and try, so then we're also ready to go. Sort of competing against Rob Gould and some other people, so I'm not entirely sure how many are going to come to the room. But yeah, it's going to be an interesting discussion for us anyway.
Yeah, so I think it's visible on the screen.
Yeah, that looks good.
Yeah, I can see it as well. Looks good.
Oh. Yeah, we'll just wait another minute or two if anyone comes. Hi.
5 days and still
Yeah. Oh yeah, for the people online, we're in this wonderful facility which has got a maze of little rooms. We're also in one of the most obscure of those rooms. Yeah, but it's really nice once you find. Okay, just a reminder for the people online that we've got about sort of 15 minutes for presenting and then sort of 5 minutes for questions and change over at the end. It's hard for me to tell you to stop since you're online, but I'm trusting that you sort of have a clock in front of you so you can keep an eye on the time. But I'll interrupt if you do go too long. Okay, well let's get started. So we do have an audience now. So yeah, it's my pleasure to introduce Dominic, who's from the Philippines and is going to be leading us through some interesting visualizations of complex algorithms. Over to you.
All right, thank you so much for that wonderful introduction. So, hi everyone. So it's evening here in the Philippines. It's 10 p.m., but I think it's morning there at this room. In which case, good morning. So this is actually, so for a bit of like a personal note, this is actually my second time to attend the ICOTS. So I was in the 10th ICOTS, which was held in Kyoto. I was there with my friends. We had just graduated from our undergraduate at the time. And now I'm back here with my master's degree. Quite some time. It's fun. It's nice to have been able to join, although I have to say, regrets that I can't really join in person, because I remember especially the tours around Kyoto were my favorite part of ICOTS, and of course the talks were good as well. So this is our paper. This is an ongoing research work that I am performing with my dad. So this is that's him, Dayta, he is a public school teacher at the Tandang Sora Integrated School in our old city in Caloocan, here in the Philippines. Meanwhile, I am a professor for statistics, assistant professor at the University of the Philippines, Diliman. So what we're trying to do here with this research is to sort of add on to a growing body of literature about the gains that we can get from using interactive web apps in the classroom. So the use of web apps isn't sort of like it's not really new, and I like to say that it's actually one of the primary features at this point of essentially one of the primary features of many works that have been presented in the ICOTS in recent years. So from the 2018 ICOTS, in fact, we have these papers by Forbes and Demirhan et al., where they show the gains essentially of showing or teaching Bayesian statistics through interactive web apps. And what really captures us, what really captures our attention with these papers is that when we think of Bayesian statistics, or we think about these really complicated hierarchical models, you have your prior distributions, and then joining them with the likelihood, they tend to turn into this really unwieldy mathematics. And if we try and teach them, let's say, to high school level students, it tends to become too unwieldy for their level. So it looks like the tendency for classroom level statistics, at least before undergraduate college, say in the high school level, the tendency is for the students to get stuck with Stat 101 type of material. So you know the usuals like the t-test and the z-test, because these are very useful statistics, but they also have the advantage of being easy to teach even in their mathematical forms. But of course, it's been observed in the literature that these level of statistics don't really capture anymore the type of analysis that they would be doing. Suppose they do work, let's say, in the industry, and once they perform experiments, it's not really enough anymore to equip them with the right tools for analysis. So there has been a movement, according to Rosman and Chance, it's a reform movement in statistics education, where we're learning more and more the benefits of using online and app-based methods for teaching statistics. So more on that subject, the past few decades, in the early 21st century, we have seen a lot of really big strides in terms of statistical methods. So we have, of course, the advent of data science with techniques like support vector machines. You have with Bayesian computation, and Bayesian computation has really been a very fertile ground for research. We have a lot of applications now of hierarchical models. And the problem there is that the actual statistical rigor needed in order to even teach these methods may sometimes be way beyond the levels for, let's say, high school level students. And like I said, the tendency is for them to get stuck with Stat 101 type of materials. So there is now growing interest into how can we introduce students to these more contemporary level statistics without really forcing them to learn like mathematics that's way above their levels, right? So let's sort of introduce them to these methods. So how do we show them that statistics now goes way beyond correlation coefficients or the t-test, but without really forcing them to learn a lot of the math? It's probably just going to fly above their heads, right? So our objective is to take advantage of the growing literature that has been produced on the subject of using web apps, and we want to create a web app for teaching the k-means clustering algorithm for students in the secondary level. So we created the web app, and as we'll see later, we asked students from my dad's school, Tandang Sora Integrated School. We asked high school students there to try out the web app, and let's see what they can learn about this method. They're wondering, why would they even need to learn about this method? So it's a good thing if we're able to finally impart to these students more contemporary level statistics. And the state of statistics education here in the Philippines essentially has really gotten stuck with like a lot of the old material. So this, if successfully done, and if it's something that we can perform finally for standardized for all schools And this would be a big help in improving or upskilling our students when it comes to contemporary statistics. So I want to go into a bit more detail about how we designed the material, and it's a web app, right? And I'd like to show you guys, show you all what the web app looks like later. But when we designed the web app, the idea is in order to give them like a modular introduction into the algorithm. So the lessons are divided into these modules that divides the lessons into this easy to digest pieces and comprehensive pieces, but are also organized such that they can get introduced gently into the topic. So right now, because of this is sort of like at the pilot level, we're focusing on just one topic, that is K-means clustering, but we're envisioning that this could be something bigger if we're able to use it, for example, for an entire curriculum of data science, for example, for the high school level. So what's different? Like, what's the advantage of using this material? Don't worry if it's too small, this particular graph, because generally when we try to introduce these methods, we end up presenting them in really flat, really sort of really static graphics. And what we really wanted to take advantage of in this application is to give them something that they can explore. It's something that invites them to explore the topic of K-means clustering. What does it mean when we say we're finding the centroid in the data? What does it mean when you're trying to make the algorithm converge towards the proper positioning of the centroids? How are they assigned into groups? So we're trying to show that into a way that lets them explore and sort of get a visual understanding of the graph, because that's sort of like the next best thing, right? We can't really make them fully understand the mathematics behind the method, and chances are they probably won't be able to follow, right, the mathematics, because they won't be suitably adopted. But if they can get a visual understanding of this method, which is exactly what these previous papers in using web apps have been able to show, once they have a concrete visual understanding of the method, then we can then help them understand the method, at least at the practical level. So to give you an idea of what the method, what it looks like, let me switch tab I'm sharing. So this is what the web app looks like for the students. So we created this website, and it gives them like the modules, and then in the modules, essentially, they're able to interact with the graph. So for example, in the lesson where we're talking about randomly placing the centroid locations into their initial states, and there are many different ways of performing the initialization, but we're doing the basic of Lloyd's algorithm, where you just randomly place them into any part of the data. They can then see exactly what we mean, and they can essentially visualize how that random assignment is going to happen. And then later we'll explain to them how cluster assignments are made, and then we can then say, all right, so one group is going to be the blue group, and the other group is going to be the purple group, and then we can see how these groups change assignment as we relocate the centroids in the initial stage of the algorithm. So the lesson actually goes even further than that and introduces the students into the updating stage all the way to the convergence. So this convergence, I think, is really something that students can struggle with if we only introduce it to them like in the formal sense, in the mathematical sense of what it means for an algorithm to converge, like talking about errors approaching a small value until they reach a tolerance. They might not be able to understand it, like, unless they're already equipped with the idea of convergence in power series calculus. So in our case, just to show them, right, so if you initialize the centers into a certain locations, and then as they iterate on the graph, then they'll be able to watch as each of the data points change assignment in the clusters, and as the cluster locations are improved. So we give them like a soft mathematical introduction into that, but the cusp of the material, where the advantage we feel really comes in, is in their ability to see visually exactly how that happens, and then they can then see how convergence is approached and what it means for the data to be clustered. So that's the material. What we did for this run is, let me go back to my slides now. So what we did for this material is that we asked, if you're interested in accessing, by the way, the web app. So right now we're trying to create a public version of the website, but what we did with the material is that we created a website where the students will be able to access the lessons, and the website itself is doing the random assignment because we're doing an experimental study here. So it's the website itself that's doing the experimental design, the randomization of the students into whether they'll get to access the improved material or they'll get to access a more traditional version of the material that's going to be based on more static kind of graphics and the likes. So we're trying to create a public view version of the website so that others may be able to access it, but the source code is actually already available publicly through GitHub. So we provide the link here, and I've uploaded to Hoover our session slides so that you can copy and paste the material. But hopefully, if you're interested, you might want to check it out. And then we're also opening, since this is open source, we're also open for some of your suggestions and feedback if you'd like to contribute to the project as well. But in any sense, what we did then is that to aid the comparison between how students perform between each type of module design, we created two versions, like I said. So one takes on a more static approach, the other takes on a more the interactive approach that I showed you, and then we created the website just to host the material. So we asked the students, since here in the Philippines, at the time that we were doing this, our classes were still mostly online, so we were still doing everything remotely. So we asked the students to log on to the website and access the website, then the website assigns which material they'll see, and that allows us to perform the experimental study. And to just talk about the results of the experimental studies, of course, now we want to go into the actual rigor part of our study, where does this work? Right? Can we then show that this experimental study have any gains whatsoever? And really, we weren't able to show just yet any significant difference between the app usage, the interactive app usage versus the other kind of versus the static approach. But we were able to show in any sense that they got, a lot of them on average got better results on the test. But numerically, we were able to show, but I think a big limitation that we had in conducting experimental studies, that the evaluation method that we used, or rather the test that we used, was kind of very small. And that's because we're only really teaching them one topic. It's all K-means algorithm. So really, the test that we were able to read went at just like 15 items. So what we're seeing essentially is that it's in the variation of the scores where we're kind of getting a challenge in getting like conclusive results. So what we're positing now is that maybe with a bigger scale of the study, more topics, and therefore by extension, more question items, it's possible for us to be able to see some more conclusive patterns in the improvements of the students' understanding of the topic. But in terms of the students' feedback, in general, the students thought that the interactive design of the web app was much more useful. And here, for example, we can see the students' ratings of how well they understood the material versus how useful they was, or how appropriate they thought the material was. Appropriateness here is their rating of how appropriate they felt the material was to their level. And we found that in general, students felt that this lesson was more appropriate for their level when they were actually looking at the interactive approach. So not only did they feel that it was more appropriate for them, they also thought the graphs in that level were much more useful for them in understanding the topic, and they were able to understand it easily as well. What we're seeing here is that it's using an interactive approach sort of like refans or makes the topic less scary for the students, because it turns into something that they can imagine, like something that they can grasp within a visual level, understanding how the algorithm works, rather than force them to picture everything starting from the mathematics of it. So for our conclusions, the highly technical nature of these topics may not even necessarily be a hindrance. So one reason why we're not really teaching a lot of the students more contemporary statistics, so we're afraid of maybe they won't understand the mathematics. Maybe once we introduce these things that are heavy on calculus or heavy on probability, then maybe they won't really appreciate or understand the topic. But it turns out that even at this level, they're able to understand the material as long as we give them a more visual approach to the material. So an interactive web app does still pose some, does make it a bit more inviting, at least from the student's standpoint. So for some changes that we're thinking, so definitely one of the ongoing the execution phase and challenges from the pandemic, since we weren't really able to compare this now with like, does this work better than, let's say, a face-to-face instruction? So that one, I think, remains to be an open question, since this was done 100% remotely. And we'd also like to compare it, let's say, instead of just the K-means algorithm, what if we do like a full blast curriculum where we teach an entire semester or an entire year of contemporary statistics to students, but using the interactive web app versus how we would do it traditionally with static graphs and with mathematics. But that, of course, that would require a bit more in terms of logistics for the study. So this actually ends my talk for today. Thank you so much for your attention, and I think we have room for questions.
Cool, yeah, thanks so much, Dominic. Maybe you should sit more forward so they can see there's someone else in the audience. Okay, so yeah, we do have a few minutes for questions. Does anyone online have a question for Dominic? Yeah, Megan?
So, Dominic, I really like this idea of having these more modern ideas in the intro stat class. The intro stat class could really use some of these more modern ideas. I was wondering what were your next steps that you were thinking about, after you kind of finished K-means clustering, what other ideas were you thinking about?
So thank you so much for that, Megan. So right now, because classes here in the Philippines have started to open up, so some schools are already offering face-to-face classes. For example, in our university, professors now have the choice of asking the students to come in and attend classes like they would have done like before the pandemic. One thing that we want to compare is how would this work alongside the traditional classroom setup. So let's say we have a fully face-to-face class where the teacher is explaining everything, let's say, on the whiteboard, versus if the teacher was still teaching them in the classroom but with the web app available to the students, versus, let's say, a purely remote web app based approach. So that, I think, is now that classes are opening up, I think that one, we have an opportunity to test that comparison. But really, on the long run, we'd like to see how we can then make like a longer curriculum with more contemporary statistics, not just K-means. Maybe we're thinking support vector machines, for example, and logistic regression, maybe even neural networks. But of course, it remains to be seen how we can actually pull that off. Thank you so much for that question.
I guess I have a follow-on question is, if students are spending time on this in the curriculum, is there something that you're removing to free up that time?
I'm scared to answer that question because I might face some backlash from more those more used to traditional statistics instruction. But actually, in the university, what we're considering, for instance, is we offer Stat 101 classes for non-statistics majors. So one thing that we're considering is maybe pull back a little on the probability theory, because we do a lot of combinatorics and like the rigorous mathematical probability theory. So we're thinking of like more visual approach to probability, but of course it's a bit experimental at this point. We're not sure yet exactly what points of probability would be like easy to remove without making everything confusing, because the probability section tends to be, I won't say superfluous, right? But you need the probability theory to understand things like sampling designs and the likes. But really beyond from that, there's really not a lot of gain, especially if you're not going to be highly focused on academic statistics. So what we're thinking of is maybe probability theory is something that we can improve with like kind of this approach to make it less heavy on the mathematics and more on how it actually applies to statistics in practice.
Yeah, that seems a reasonable suggestion. Marcus has one here too.
Yeah. Hi Dominic, it's Marcus Hacklitz from Germany. Thank you very much for this very interesting talk, because I read recently an article by Wang et al. About student-developed Shiny apps, which sparked my interest in this topic. Are you familiar with that journal article?
With the paper, I'll have to check that out. But Shiny apps in general, I've read a number of other articles around Shiny apps, and I think it's an interesting direction.
Because I would have been interested how you would compare your research to that, because also in this article, while it proved to be successful, especially with the students developing those apps themselves or under instruction of the instructors, but they question a bit the long-term learning effectiveness of that. So they go into this one topic, and I was wondering if maybe your approach also, I think it goes a bit more in depth in terms of explaining the concepts, while those Shiny apps are more like demonstrating the concept. So maybe it would be interesting to jump onto that and maybe take a look if that's a solution, how you presented it to give more explanations in the web apps itself. So maybe just as a suggestion or something to think about.
Thank you so much for that. I think that's something that we can check out, because I think with Shiny apps, I think it's going to be more of a demo approach, but what we're trying to do here is more of like still pedagogical, right? We're still trying to teach and explain this algorithm, but like give them a visual alternative to the mathematics. But I think in the long run, it's good to explore like the learning effectiveness of this, if we can actually impart them with the understanding that they actually need to get beyond just letting them or demoing to them how the algorithm works.
Cool, thanks so much. I've got some more questions too, but we're out of time and I'm actually the next speaker, so I don't want to use up my time to ask.
Thank you so much.
Please thank Dominic again. Okay, so I think I'm the only one who's speaking in the room, everyone else online, so yeah. Not exactly sure the online people, they can see